Wait, are there any questions?
Oh, yes, we have questions. Well, I have questions. Do you mind going over this question right here, question 5D? I know the angle because I was like plugging in the Pythagorean theorem in my calculator, but when I try to solve it, it's not working out.
So the 5B?
5D as in dog.
D as in dog, okay. All right, so this is basically the lab. This is centrifugal motion lab. All right, so looking at the side force diagram. So we'll have a tension acting up at that angle right there. This is supposed to be parallel. And weight acting down. That angle right there is theta. This is the fall 2017 test. Test 1B. All right, so that's the answer to part A. I know you wanted part D as in dog. Part B is what is the radius in terms of the quantities that we're given. We are given the fact that that is L, that's mass of M, theta, on some planet G, and spinning around at some speed V. So part B was what is R, radius of the circular path. So in which direction, this thing is spinning around like that, in which direction is the radius?
This way.
Okay. Were you pointing at me?
No.
Okay. It is indeed towards the middle. So as it spins around, it's constantly, the acceleration is constantly changing direction, but it's always pointing towards the middle. So R is this distance here, and so the question for part B is what is R in terms of the other things that we know. And well, we have a triangle right there. That hypotenuse is L, that distance is R, that angle there is theta. So R is equal to L cosine theta. So that's all it is to that. Equations of motion. In terms of the same unknowns. So even though we'll set up the equations of motion like we typically do, we do need to do enough substitutions till we get in terms of the unknowns that we have there. So we need to break up what?
The tension.
Yeah. So I have weight acting down. The tension is going to the left and up. So this is the tension times the sine of theta.
Yes.
This is the tension times the cosine of theta. So what are the equations of motion?
I have is
coordinate axis.
yes, and then so I has gonna be ft cosine.
So Talon, what did you say?
Oh, when it goes to axis, as you're literally doing it.
Okay.
Coordinate axis.
I has ft cosine theta equals mass times acceleration, centrifugal acceleration.
Okay.
J hat is ft sine theta minus weight equals 0.
The variables that are allowed in the final answer are M, L, theta, little g and v.
Yes.
Oh, and the tension in the chain. It's symbols for everything, but tension in the chain I just wrote out.
And then you do Ft sine theta equals mg. And then I divided them.
Well, we just need the equations of motion right now.
Oh, sorry, I don't remember the question.
So we need to get it so that we're only using these variables here. So obviously we have tension, m and g, so that equation is good. This equation has centripetal acceleration, so we do need to deal with that.
Yeah, centripetal acceleration equals v squared over rg. I mean, v squared over r.
Stop.
With,
So we have the tension times the cosine of theta is equal to m v squared over r. Now,
and then we just
all right, so
to r.
that would be the answer to part C. Part D.
Oh, it
We
doesn't.
can't use R.
What?
I don't think we can use R.
We're looking for r, so r kind of has to.
Oh, that's true.
In the equations.
R is not one of them.
It's okay.
Well, we know an equation for part B, we know what R is equal to, so we make that substitution. So this becomes Ft cosine theta is equal to m v squared over L
Cosine theta.
cosine theta. Alternatively, we could have done Ft cosine theta is equal to m omega squared r, or Ft cosine theta is equal to m omega squared L cosine theta. Which might have been the simpler route.
So omega wouldn't be a variable.
That's true, omega's.
I tried to use omega the first time too.
Nope, then what we had the first time. So this is what you would need to do. Okay. Because indeed, omega is not. The angle below the horizontal, the mass sags, looking for a number. So we have the mass, 7.26 kilograms. L is 1.22 meters. V is 4 meters per second. And let's put it on Mars, I said, so 3.8 meters per second squared. And I'm asking for theta.
Oh my gosh.
So we're just supposed to use this then.
We just use, yeah, don't we just use one of the equations of motions then?
Well, presumably at least one of them.
That
So you know M and G. I don't know theta and I don't know tension.
is true.
But I have another equation here with theta and tension in it. I know V, I know M,
You know L.
I know L. So I have two equations, two unknowns. It depends on how you, at this point it's a math problem.
You just want to.
Do the math problem?
Yeah.
This would be
All right, so I'll plug the numbers in a moment. So I have tension times the sine of theta is equal to mg. From that other equation down there, I have tension times the cosine squared theta equals
Wait, where are we doing?
mv squared over L.
how'd you get this in cosine
Oh,
squared?
because
You're multiplying the cosine times the Ft cosine theta.
I didn't multiply by L because I know what L is. I basically have it set up, my unknowns are on one side, my knowns are on the other.
Would Ft equal arc mg arc sine theta?
Wait. Say that again?
Would,
Tension equal mg arc sine theta, is that what you said?
yeah, but I don't think that's right, sorry.
It'd be mg divided by sine theta.
Yeah.
It would have been simpler.
If we knew theta,
Let's see.
but we don't.
Omega, we don't really know. I was thinking there was some simple way, but potentially not. I mean, it's the fifth part of a problem, so it just could be just the tough one. At this point, trig substitution. What we need to get in terms of a single variable here. And yes, we have theta and theta, but with trig, sine of theta and cosine theta are related to each other, but they're sort of intertwined very closely.
Are you asking the Pythagorean identity?
That's the one.
Cosine squared theta plus sine squared theta equals 1.
Therefore, this becomes tension times 1 minus sine squared theta is equal to mv squared over L.
Yeah.
Do y'all get that? I can write it out for you.
Wait.
It's on the thing. You just did.
Oh, you're just doing that? Okay. No, I'm
Just doing that. Yes, presumably. So we have tension, actually, I'm going to hold off on that one. Let's solve for tension in this equation. That becomes the tension is equal to mg over sine theta. Plug that into there. So I have mg over sine theta. 1 minus sine squared theta is equal to mv squared over L. Now I'm going to multiply by that by the denominator.
On both sides?
We got to multiply both sides by sine theta.
LMG times 1 minus sine squared theta equals sine theta mv squared
LMG.
times 1 minus sine squared theta.
All right, at this point, I get tired of writing, so I'm just going to use S is equal to sine of theta is equal to
Equals-
mv squared S. Now what?
Substitution, I believe.
Or what?
Hold on, no, we have to FOIL first, don't we?
Distribute. FOIL is if you have two binomials.
Okay, well, distribute. So LMG minus S squared times LMG equals MV squared S. Well, I think we can take out M.
Yes.
How did you get rid of the sine theta in the denominator, on the thing on the bottom?
Multiplying both sides by the sine of theta, L sine theta, just to get rid of the fractions.
Got it.
And I'm just using S because I'm lazy. Efficient, sorry, not lazy.
A good time manager.
All right, so how do we solve it?
Can we substitute L now and V and
Substitute, what would you substitute in for L? We know the number. L's given in
we
the problem.
don't? I don't have a problem on.
Yeah, I wrote the values of what we
Okay,
do
I
know
didn't
right
see
here.
that. L is 1.22 meters.
Oh,
And
you want
then-
to put the numbers in now? That's what you're going for?
Yes.
All right, I'm going to start a fresh screen here. So we've got LG, S squared LG. So LG minus S squared LG equals MV squared.
No, we took out M.
Thank you.
V squared S.
All right, when we're trying to find an angle and it's wrapped up in a trig function, you have to solve for the trig function first. So we have to solve for either the sine of theta or the cosine of theta, and then we'll do an arc sine or cosine. Since we have everything in terms of sine right now, it makes sense to solve for sine of theta first.
Yes.
So we're solving for S.
Okay.
I'm seeing that since it's sine squared and then there's a sine on the other side, and then there's an LG, then we can make a quadratic equation out of this.
Absolutely.
Oh my god.
So I have 0 is equal to LG sine squared plus V squared sine minus big LG.
Can we substitute now, or do we do the
Oh, you want
quadratic?
to plug in the numbers? If you want. All right, so we have 1.22 times 3.8 s squared plus 16s minus 1.22 times 3.8. So whatever that is.
As in calculate it?
Yes.
$4.636.
4.636 s squared plus 16s minus 4.636 equals 0. And at this point, quadratic formula. So the sine of theta equals negative 16 plus or minus the square root.
Can
Maybe
you hold
look
on?
at the
Can I
other
write
one.
that down before you go ahead?
Oh, that is 16. So v squared, that's, yep, I was right, 16.
I don't know.
I forget, dude.
I mean, yeah, actually, you're right.
Okay. The answer is 0.2688. Yeah, and then we do. Oh, is there gonna be two answers?
No.
One of negative 3.72. And then we do arc sine.
Sine of theta is equal to this, so to get theta isolated, basically do the arc sine of both sides. So I have theta is the arc sine of 0.2688, or conceivably the arc sine of negative 3.72. What is the arc sine of negative 3.72 without using a calculator?
15.59.
What in the world? The log world. Is it
that's-
negative? Oh, it's gonna be
Point
notice.
two.
It's just
Yeah, it's
gonna-
undefined.
Yeah.
It's 0 or whatever.
You can't do an arc sine of a number bigger than 1 or less than negative 1. Because the math people haven't figured out yet how to do that.
Wait, Dr. Fox, I have a quick question.
Yeah.
So I tried to map this out with my calculator, right? And correct me if I'm wrong, but if the length is equal to 1.22 and that's the hypotenuse, the horizontal and the vertical is length cosine theta and length sine theta. And I know why, like in the text you put down like this is the hardest question, make sure you know that cosine squared plus sine squared equals 1. But when I was putting in my calculator, I'm getting 10 degrees. I didn't do it the same way you're doing it, but I'm just saying, like, if I use the Pythagorean theorem, why is it wrong?
Are you in radians or degrees or something?
Where did you use Pythagorean theorem?
You know what? You know what I think I did wrong? Let me show you. I mean, actually, let me see. Plus 1.22 squared. Yeah, I don't understand. Why is this not right? The degree would be 10, and
Close.
that's the hypotenuse. And then this would be the vertical component, and this would be,
You should get 1.22 squared.
which is this. So why am I getting 10 degrees, but you're getting 15.59? Is this like mathematically flipped or something?
Well, it doesn't, well, no matter what angle that is, you're still gonna get the same value.
What? 20.
Oh, dang, sorry. I must have put it wrong when I wrote it.
I got so excited
All right.
with everything.
So if this angle was 15 point something degrees? Or
15.59 degrees.
And answer.
You had a question again about that? I didn't have a question.
Well, not sure.
And on this one, I had missed it when I scanned it before, where I did write, this is possibly the toughest question on the test. Remember that sine squared equals cosine squared equals.
No wonder, I was like, why is this only for a question? Wait, yours doesn't have it at all? Yeah, it does. I wouldn't put it
Give up halfway.
I do want to point out, having looked at the quizzes, that if you're doing angles in degrees, you can't just mysteriously drop that unit if you feel like it. Radians you can drop, degrees you can't.
Sine squared plus cosine squared equals what?
1. Alright. Any questions about this? I believe it was the fall 2017 test 1B. Problem
You
something.
should totally not put that question on the test.
You jinxed it.
Actually, don't put any of the questions from this one on the test, because this one was actually really hard.
2017.
The 2017.
But I've just gone through the problem.
I
If I
understand,
put
but
it on
like
the
the rest
test.
of the questions are
Honestly, the
like,
warm-up was great.
yeah, the warm-up was good.
The test is set.
You must have really loved your 2017 class, because I was struggling. Okay.
Other questions?
I do have a quick question.
Ava.
So for number 8 on that same test, we were asked to do a force diagram for an image, and it requires you to like, there's 2 angles in terms of alpha and beta, and I'm not entirely clear on how we're getting like the alpha plus beta angles. So we can do an example for that.